Okay, I was asked to do a quick video about question number 2 from lesson 6. So I've taken the liberty to just enter the part 2A, its scatter plot. Oh, went away, there we go. Entered its scatter plot into Google Sheets already. So we'll just go through the steps after you enter the scatter plot. So I'm going to highlight my scatter plot and go Insert Chart. Now it has already selected that it is a scatter plot. And if we take a look at it, it looks roughly quadratic when you're taking a look at it yourself. But how do we know whether it's quadratic or not? So let's go in and customize this thing. Where you're going to need to look is in the Series tab. And if you go down, we want to put on the trend line. Now it's going to start by putting a line on it, but we don't necessarily want a linear relationship. In fact, I think we do not want a linear relationship. So we have to look at the other stuff that's down here. So I'm going to change it from a linear to one of these things. Now to me, it does not look exponential. It does not look logarithmic. It does not look like a power series. It looks like it's some sort of polynomial. So we're going to click on polynomial, and it's going to start by putting a quadratic on. So when you take a look down below, it tells you the degree of the polynomial. So a degree 2 is the quadratic or the parabola. So if you don't like the degree 2, you can try some of the other ones, move it up by a degree. But let's have a look and see what it actually thinks the R value is for this one. So the R squared is 0.966, which is actually pretty strong. Okay, so it is most likely a parabola, but let's label it with the equation, which is right here with label. So we have the equation there. And if you were going to write this down, you would write this x with the little up arrow too. You would write that as x squared. So this is the whole thing. Y equals 4.64 minus, don't put in the double signs when you write it down. So if I ask you for an answer, write it down the way you would in math class, not the way the software gives it to you. So 4.64 minus 2.46x minus 1.43x squared. Now that's a pretty strong one. Let's see what happens if we increase the degree. So it looks like it got a little bit better. Okay, so you could go with the cubic if you want to, but it's not that much better that I think it would necessarily mean anything. Once we start getting into the higher ones, it's going to still try to put something that looks like it fits those points, but it's starting to get a little silly actually when you look at it. And if you get enough points, like this one looks like it almost goes through all of the points. But if you have to watch it. If you don't have enough points, a higher degree parabola can go through any sets of points, or sorry, not parabola, but polynomial function can go through any sets of points. So it is going to get better and better the more you go, but that's not necessarily means anything. And if you want to see really what's going to go beyond the scope of the points that you're given, you can go into the horizontal axis and set your max and min value outside this range that we have here. So this goes from -2 or -4 to +2. Let's have it go from -10 to +10. So I'm going to go -10 to +10, and you can see what it's going to look like. So we really have no information beyond these 2 points. So to think that it's going to go back up again is maybe not the smartest option. Okay, so I wouldn't personally go that high in your parabola or in your, sorry, polynomial functions. So I think probably if we go back to series, that a quadratic would likely be good enough for this. So let's go back down to degree 2. And it looks like it roughly fits the data. There's nothing, it doesn't go back up at the sides, so it's not doing something that we can't say about it, but it's a pretty good fit with just a parabola. Okay, I hope that helps.